Is sound working? Indeed it is. Well, we have that covered. All right, we're getting a bit of a later start than I wanted, but here we are. Let's see. All right. Okay, just making sure that all of my entire screen shows up. Yay. All right. I fixed that problem. So what are we doing here? Well, just a second. Let me check on something. Okay. So let's demonstrate what's going on here by running a test. Um, Mapper testing. All right. All right. Well, that's interesting. It's not what I was expecting. Hmm. Well, huh. That's upsetting. Let's look at here. All right. So it looks like I'm going to have to mess with the test a little bit. Oh, how annoying. So where's mod mapper main? Import main. So this main right here as mod mapper main. That's fine. This is where the logging is set up. Should do a chdir before it calls mod mapper main, which is where the logging is set up. So what's going on here? Maybe this? Huh. I'm querying an LLM about what's going on here. Oh, this is complicated. So what's going on here? I have this test. I also have a bunch of things in the test library. Tests. Hmm. Let's see here. Test. Maybe I shouldn't do the RMDir first. Let's try doing it that way. So I'm trying to figure out how to get logging to work the way I want it to here. Okay. Oh, I guess I'll call it logger. Here, logger. Here, logger. Here, logger. No, that's not what I want. Let's see here. Let's look at the diff here. Hello. I am writing Python to do, well, right now I'm trying to get logging outputs to demonstrate what it's doing, but I'm not able to get the logging output when running it under PyTest, so I'm trying to fix that problem right now. So basic config, yeah. Oh, this there. I really, really do not like how CLion does not handle focus follows mouse very well. And we'll do formatter. I think that's how this works. Or is it something else? Let me check. I'm using an AI as a manual here. No. All right. There we go. That should do something now. I angered the Python formatting gods. I do not think so. Okay. There we go. Now we can see. All right. What's it doing? What? uh, all right. Let's try this one more time. There we go. Good. Oh, you can see what the protocol looks like. So here I'm trying to compile this file top impl.cpp. You can kind of see that from the actual test here. I'll skip these guys. You can see that from the actual test. So the actual test I'm running with this, like modules, March, tune. I probably don't need these two options for the test, but what the heck. Standard C++ 23. And then I'm basically compiling this file and putting it in here, right? But here's the command that actually gets run. Basically G++ and then all this stuff. So, no, source O. And then I have this thing where it's basically redirecting all the module mapper communication to file descriptor 15, whatever that is. So input from file descriptor 15 and output to file descriptor 15. It happens to be a socket pair, but I'm not worried about it too much right now. And then we'll also have a label here that comes after the question mark, and that label is at top for the top level compile. So then the actual meat of the module mapper runs, and it gets here to start. And then it gets these command bundles. So these are communications from GCC. GCC is telling us, hey, I'm GCC, compiling at the label at top. And then it also gets as a second command. This is the first command, and then the second command is, hey, and I would like to know what module, where the module repo is. So then I parse it. Ah, yes, here's the module. No, here's the here's the command bundle here. All right, here's the parsed of it. So it splits it all up. Goes, ah, yes, I understand the hello command, or it doesn't even do that. This is just parsing. So then it gets this is the thing to parse words module repo, and then it goes, oh, the in between here, there's a bunch of protocol handling where it goes, oh, I know the hello command, and I know the module repo command. It parses both of these things as part of a command bundle. These are two separate commands that are bundled together. One of the things that it doesn't show here is that GCC actually puts a semicolon new line at the end of this command here to indicate that there's a continuation. A second command is part of the bundle. And so it processes the whole bundle at once, and then it replies to the whole bundle at once. And so its reply is, yes, hello, I also speak protocol 1, and my name is Python CPP server. I should probably change that to PyCPP mod mapper. And then I have the semicolon backslash n there going. And then my response to your next command as part of the bundle is the module repo is here, right? So then I get this thing from GCC saying, include translate. Where do I find this thing? And I just respond with, just carry on. I see where that conclude. You want to include that file from there. That's just fine with me. I don't need to do anything with it. So GCC does that, and it sends us another one. We reply again. So it just sends us all these include files, and for each include file that it wants to use, it just tell it, yeah, go on. That's where it is. Finally, we'll get to all the end of all of the include files here, right? And then, more include translates. So let's get to the end of all the include translates here. There's a lot. Oh, there's a lot of them. Oh, So then we say, we need to import a module, the top module. And so I say, the top module. Well, that means I need to compile the top module. So we're going to compile this module with this command. F modules, all the other options that I gave before, but this time the output is this thing here, which may not produce any output at all. But if it's going to produce output when compiling the object file output when compiling the module, that object file output will go there. And for the module name itself is right here. That's where you find the module input file. And this is like, it figures out, modules, and the module name is top. It is going to be found here, right there at that spot. And then I then do module mapper again, and this time it's file descriptor 19. So now this module mapper is actually communicating with two sub GCC processes, one on file descriptor 15 and one on file descriptor 19, and getting like information from both of them. So this is the start of the communication with the compilation for /top, and I basically give like the module name with a slash in front of it as the label, right? And you can see that here, right here, when I'm in the GCC command that it executes. And it gets the command bundle again from GCC going, hey, I'm a GCC and I'm, I've been told that my label is /top, and yeah, I want to know where the module repo is. I figure that out and go, yeah, I'm PyCPP server, and your module repo can be found here. And then it also tries to get me to do a lot of include translates. I'm not quite sure what I'm including in the top module, but apparently I'm including a bunch of stuff in the top module. Or maybe this is left over from compiling the top impl file. I'm not sure. Oh, nope, it's the top module. Actually, you can tell because it says /top. So I think if I go and look at, if I go here and look at the test CPP project and modules and look at top.cpp module, yep, I include some stuff in here now. So, yep, indeed. Yep, concepts and a bunch of other stuff. Type traits and limits. So, go, is where to find all these things. Or it asks me, I want to do this include? And I say, yep, that's fine with me. That's where you find it. That's what bool true is. That's what that response means to the include translate message. Then after I do that, I say it tells me module export top, basically going, I'm doing this compilation now, and I need some place to put the compiled version of the module file, the GCM file. And I say, oh, the path name for that is blah 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 blah, ending in top.gcm. And then it tells me, all right, I've done it. I've compiled the module. And I go, great, that's great. And then that communication ends. And then I resume communication with the top level compile saying, hey, yeah, the top module that you were asking for that I just compiled, but it doesn't know that. All it knows is it asked for where the top module was, and I took a long time to answer. Otherwise, it doesn't know that I just compiled it. And so I'm saying, yeah, its path name is blah blah blah, which is where it got put. And it goes, oh well, that's great. And oh, why does at top start again? That doesn't make any sense. Why is, oh, I know why. It's because this is the next compile. So I'm doing another compile. That's what the start is all about. And this compile is for main. So I'm compiling main. And then I say, hey, I'm GCC and I'm called, for at top, and I want to know where the module repo is. And I say, hi there, I'm Python CPP server, and the module repo, you can find it right here. This is where it is. And then it goes, I need the module top, and I need the module, in middle A, and the module middle B, and the module bottom. And I go, oh, well, that's a lot of stuff. So I start about compiling it all. I start off a compile going, hey, I need to compile top, and so on and so forth. I compile top.cppm again, and all this stuff happens. I've been programming for about 46 years. Yeah, I've been programming since I was, for about 46 years. I've been programming in Python for about 25 years. I've been programming in C++. I wrote my first C++ program probably, let me check. 37 years ago. Yes. I wrote my first C++ program when C++ was barely a twinkle in Bjarne's crucible. Wow, okay. More than a twinkle. There was an actual, implementation, but it was the very first implementation called Cfront. I used it. Do you know C++ at all? By the way, I compile top multiple times here because I don't have any dependency checking implemented yet. So I compile middle A wants top, so I got to do it again. And then I do middle B wants top, so I got to do it again. And yeah. And bottom wants middle A and middle B. And so then I have to do middle A again. And then I have to do top again. And then it wants middle B. And then I have to do middle B again. And then I have to do top again. And yeah, it's much longer than it needs to. Anyway. Are you familiar with it's a fairly recent and not well supported? So it's a fairly recent and not well supported feature. I think I'm comfortable saying that. called modules. Is it a feature that you're familiar with in C++? It's kind of intended as kind of a replacement for pound include. You're from YouTube. Here, I'll show you what it looks like. I'll show you the test CPP project I have here. This is what's being compiled with all this nonsense that's going by on the screen that I'm kind of going over just to sort of introduce people to what's happening. So I have this modules directory, which has a bunch of modules. These are like header files, but not. And then I have the source directory that has the actual project source. If you look at the source directory, you notice I'm not including anything. I'm doing all these imports for these modules. And so if I let's look at one of the simpler modules, like modules, and then we'll go middle A, .cppm. This one it's a module file, and then it says export module middle A. And also I wrote it using Emacs, so it has Emacs droppings at the top. So I'm saying this is a module called middle A. And then I say I want to import the top module here because I'm going to use it. And then I say export. So this is saying this function is going to be part of this module's interface. It's like a public function. So export inline void MOPUS. This stands for middle A print something. That's what it stands for. And it calls print something, which is a function that's defined in top, saying I'm in middle A, right? The reason I did this is it's essentially a little diamond include pattern, right? So look at middle A and it includes top. And if you go to bottom imports middle A and middle B, but middle A would import top. And if you, we'll do less on this one because it's bigger because I added a big function to it. This one actually has includes, which is something you can do in modules. And you start at the beginning saying, this is going to be a module, just to tell the compiler that it's a module. And then when it does all of these things, the symbols that show up like from all of this stuff, the compiler kind of ignores them in a certain sense. Like the symbols appear so that I can use them, but they don't appear in the module interface in any way whatsoever. They're not private or public or anything. They're just things that I can use here. And then after I do all the includes, and I have to do these before I do this, because if I did them after I did this, it might be confused and think that these are now part of module top, but they aren't. And so I have to do them before I say module top. Then I say export module top. This is the top module, and then I give the name of a bunch of functions that are part of the module's interface. So I have a print something and a print value function. I have 3 print value functions that are overloaded for various types. I didn't want to have a template here, partly because I wanted them to not be inline. I wanted them to be functions that are actually defined in a file someplace. And if you have it be a template, you can't really do that. So you have to have the implementation right here. And the reason I wanted it is the implementation uses IO streams, and that's a big thing, and I didn't want to include IO streams here. So, and then here, all this is basically to implement an integer power function is what this is all about. Because using the fast algorithm, and also it's const expr and a bunch of other things. I wanted that as part of my testing. And so the top module is reasonably complicated, but it mostly all it defines here is that there's these functions, and then it exports this template. I don't know that I need this to export. Like this is a concept called numeric, and I don't know that I need this to export. But this is a generally useful concept, but I don't know that I needed to export it. I can use it in here without exporting it, which means that when somebody imports the module, they don't get this name. They only get the other names. You only get exported names when you import a module. So I might actually remove the export there. Anyway, that's how modules work. And if you look, there's a top impl, right? So if we go here, source top impl, there I say, oh, this is a module. And then I say, before I do anything, include IO stream so that it doesn't consider IO stream to be part of the module. And I go, this is module top. And notice I don't have export module top. So that's a sign this is an implementation file for module top. And then I have a whole bunch of stuff here that's the actual functions. You know, I have all these functions that I exported in module that I didn't define. Like the one template is all inline, right? And so I defined it here, const expr. Const expr implies inline, but that's, you know, all here inside the module header file, the module file. But then in the module implementation file, all these other functions that I exported, that's where they're defined right here. And so modules are kind of like an alternative to the whole pound include system that exists before. And they're a lot faster, partly because they get precompiled. Like if I actually was doing dependency tracking, I could avoid compiling the top module over and over and over again. And so there's like an output format called .gcm. And if we look here in, let's, after testing, and we look here in test CP project 0. This is basically a directory that was created by PyTest. In GCM cache, right, there's the prototype directory, and this contains all these GCM files that were generated by the compiler. These are not object files. Like if I do obj dump on them, and then do -- disassemble. This is Linux, by the way. It's something that you can do in Linux, and you can do this with any file. It says, oh well, this is an ELF file, but there's nothing to disassemble in here. Like if I went here into say build / top-impl, there's a lot to disassemble in there, right? This is like the print value functions, and the print something function is in here, right? That's all the stuff that's in the top implementation file. So normally, you know, you can disassemble these things, but this you can't. Now it does have obj dump can do just more than just disassemble. If we do this, it has a lot of commands. And if we go up here, I think there's a something to force all the sections to be listed. Yes, obj dump -x. So if we do -x, we can see what ELF sections, whatever ELF is, see what ELF sections are in here. And it will tell you, oh, there's all these ELF sections, and these are sections that are used to store like binary data. That's kind of the pre-chewed version of the module. So the compiler goes through the entire module, it kind of pre-parses it and pre-chews it, and then it spits something out. So then when you import the module, the compiler can just go and get all of that stuff into memory all at once without doing a minimal amount of parsing. It has to do some fix-ups to fix up like the pointers and stuff, so it gets the data structure back again, but that's really fast. And so it basically sets it up so that like the include system, the include system is like a full textual include. Like it basically replaces the pound include with the contents of the thing that you're including. So the compiler has to parse the entire thing every time you include something. Every time it parses a new file and you include something, has to parse the whole include file all over again. Modules are a way to basically have the compiler kind of spit out a pre-chewed version of a header file that it can then just import. But it also is something about like the fact that you have to explicitly export names from modules and stuff also means that modules give you a lot more control over what names are visible where. So that's really helpful and a lot better than the way header files work. Like header files, you put a pound define in a header file. You could include a header file that did something like pound define open bracket, because you can do that, pound define open bracket to be something else. And now every time you use open bracket, it doesn't mean open bracket anymore after you include that file. And that's just, yeah, that's that's very weird because of the textual nature of pound include. And the textual nature of the CP processor. The CP processor doesn't know anything about C or C++ at all. All it knows is about tokens, and it replaces tokens with other tokens. That's all it does. Yeah, that leads to some very bizarre results. Whereas modules behave much more sanely as far as the language is concerned, and what names do what where. So that's the other reason why they're used, and that's the reason why there's all that export stuff. Like you have to export things in modules. Anyway, but the compiler as it's going along, uh, source main.cpp, right? It compiles this and it gets this import statement. Well, where does it find it? For include files, you have this thing where you tell the compiler, oh, all the include files, you go and look over here, there's a path that you search in for include files. And then, it searches for the file that you included in that path. And if it's there, then that's great. It found it and it just textually replaces it. But for this import, well, maybe you could give it the module path, but then what's it do? Like, does it compile the module? Well, if it's doing that, that's kind of not the right thing to do, right? Because maybe the module is already compiled and it can get the pre-chewed version, which is what it's supposed to be trying to do. But if it goes to look for the pre-chewed version, well, maybe nobody's compiled it yet, right? And so it might not be there. And so you can't just give like a path to search for all the pre-chewed versions because the pre-chewed versions might not exist yet when it does the compile. And so that's a really weird situation, which the compiler kind of has to communicate back to the build system going, hey, I need this thing. Where do I find it? To give the build system a chance to build it if it needs to be built. And so that's what this whole module mapper thing that I'm writing in Python is all about. The compiler is communicating back to the module mapper going, hey, I need this module. And then the compiler has to, or the module mapper has to say, oh, I don't have it for you yet. Let me run the compiler again and make it. Hello there, Mr. Sir Elfman. We have a visitor from YouTube as well. And so you guys can't see each other's messages, sadly. I'm on Twitch, by the way, Ostap Vital, as well as YouTube and Rumble. I'm on those three places. And Sir Elfman is a Twitch person. I'm making a C++ module mapper. And yeah, I don't know what to do about that. I need some way of having the chats combined so that this isn't confusing for people who are joining from different things, that they can see each other's messages. Currently, I'm using restream.io is what I'm using to send this all three places. But I actually need to compile OBS for myself and then get the libitem up and running. But then I'm not quite sure what to do about the chat combining. I don't know if the item extension for OBS does that or not. And if it doesn't, I have to think of a different solution. Because, yeah, the way this is it's kind of confusing because you can't see Ostap Vital's messages, and OSTAT Vital can't see your messages. And also, uh, I don't have a good way of seeing who's on any chat but Twitch. And so I can't even tell if OSTAT Vital is still here or not anymore. Um, uh, but anyway, I'm writing a C++ module mapper in Python, and it works. It just does a lot more work than it needs to, because every time it encounters an import statement, it recompiles the module, including the import statements that are inside the modules themselves. So that's the next step, is to implement. Yay! I'm glad that you are still here, OSTAT Vital. Um, uh, the next thing I need to implement in this module mapper is um, I'm getting logging set up so that but is dependency tracking. And I've set up something preliminary for it. I have this dependency DB thing in Python. It's going to be using LMDB, which is a M-mapped thing like Berkeley databases, M-mapped key value store. And going to use that for the dependency database. I have these types here like module dependencies. Well, I need to know about the stat data for the module source file. Stat data being things like file size, modification time, all that stuff. Because if any of that changes, that probably means that the file has changed. And I don't want to read the file and hash it and all of that stuff. That's just kind of annoying. And so I'm just going to rely on the stat result. If the stat result is different, I'll assume the file is different. If the stat result isn't different, I'll assume the file is the same, even though it might not be. Um, but then the other thing about modules is that modules have modules that they depend on, like what modules were imported while this module was being compiled. And then it has headers that it depends on. And if any of those change, then maybe the module needs to be recompiled, right? And so that's a thing that I need to keep track of here so that I can accurately assess whether the module needs to be recompiled or not. And then for headers, all I really care about for the header is the stat information. I'm not here to recompile things. I'm here to recompile things if headers change, but I don't need to care about what headers depend on what other headers or anything like that. That can be handled by the rest of the build system when it's compiling the normal source files. I'm only about modules, and for modules, I don't need to care about the actual topology of the header includes. But also the key, like for a module, I care about the module name and then the whole set of the hash of all the compiler options that were used to compile the module with. So that, because there's basically, if you compile with -02 versus -03, well, that's different, right? And I need to track that. And then there's the header path is all I really care about for the header key. That's the only key that matters, is the path. Because headers are recompiled every time you compile a new source, a new compilation unit anyway. And so it doesn't, you don't have a version of the header that was compiled with a particular set of flags. So I don't need to care about the option hash for headers for the key. I have this stuff for storing things. I need to actually make things that do a little bit more. The reason why I have this class here is I'm going to have store key and retrieve key. I might actually have the dependency checking put into this class here instead of someplace else. I don't know yet. I haven't decided. Mostly what I've done so far is set it up so that the logger outputs to a saner place. I also think I'm going to change the name of the thing as reported to GCC to be, I think it's a little confusing the way it is right now. And so ID, no, this is the reply to the include the module repo. No, the hello. my hello reply. So hello. Yeah, we're not going to call ourselves that anymore. We're going to be the there. All right. Are you at all familiar with libcody, Sir Elfman? Oh, nope, Sir Elfman disappeared. Anyway, there's a GCC thing called libcody. By the way, standard format is fantastic. I actually think that standard IO should be replaced. Like we shouldn't be using IO streams anymore. GitHub. And actually, this gets to be put here as part of the C++ tab. libcody. This is basically the C++ implementation of the protocol that I'm handling here. So, yeah. And it talks about what the problem is being solved here. This is probably really tiny, so I'll just put it there. That's where to find it. It's a slightly old version, but the current version hasn't changed much. Nathan. He's not just Nathan, he's the Nathan, like the original Nathan, the Nathan before all other Nathans, the Nathan that defines Nathanness, the Nathan. uh, Actually, I'm kind of curious. Original, earliest, primitive. Yes. So the Nathan. uh, let's see here. First of all, I should commit these changes. Oh, yes. Here. There we go. And then skip remaining changes. I like Mercurial instead of, I'm using Fedora, but I'm thinking of switching. I'm thinking of switching to CachyOS, which is an optimized distribution of Arch. But so far, I'm using Fedora. One of the problems is I'm also using bcachefs as well. Turns out that the creator of bcachefs has decided his AI is sapient. And that makes me question the quality of anything that he writes from now on. It's a little too far off the deep end. Okay. Oh, you're back. Sir Elfman came back. So let's see here after committing that change. So I have this thing about changes. Changes should be focused on one task, one change, if at all possible. Changelog messages should be simple to the point, but also a complete description of the change. Uh, and yeah, you should avoid mingling changes. Each change should bring the whole thing from a working state to a working state. Um, there shouldn't have a set of changes where the thing isn't working in the middle of the changes. Those are the rules for changes. Um, I think that the AI lied about PyTest getting confused by my whole deleting the directory it created with maketemp, but I'll just do it this way anyway. It's no skin off my nose if I make copy tree do the DIRs exist thing. So that's the next change I'll fix. So the best way of learning almost any programming language, in my opinion, Ostet Vital, is to dive in and start writing programs. Start with something small and work your way up. There's no substitute for actually writing stuff. And so I would pick a thing that you would like to do in C++ that is pretty simple, and then write a little C++ program to do it. And once you've done it, then you can pick a C++ program that's slightly more complicated, or maybe extend your simple C++ program to do something a little more sophisticated than it does, and just continue along that path. That is what I would recommend for learning any programming language, not just C++. One of the big hurdles in learning C++ at the very beginning is that it's confusing to get an environment up and running where you can compile and run programs. And that's the most important thing. And that the thing that you can do there is just run the compiler on a single source file with the output being the object file. If you're using Linux, you can just do like g++ something.cpp -o program, you know, like something like that. And then after you do that, you can do /program name. If it succeeds in compiling, then you can just do that and it'll work. That's what I would recommend. Sir Elfman here just asked about something called ASAN poisoning. ASAN is the address sanitizer, which is a feature in C++ implemented by most C++ compilers to catch certain kinds of memory errors that people are prone to making in C++. And I do not know what ASAN poisoning is. And I don't know why it would be useful in writing your own allocator, your own version of new, basically. So I'm all ears, or well, eyes anyway, since I can't hear Sir Elfman talk. Oh, okay. So ASAN poisoning is just a way of telling the sanitizer that, hey, this memory, it's you shouldn't be touching it. Anything that touches it is doing something wrong. Which I can see why that would be very useful when you're writing your own allocator, because then when somebody frees something, you can say this is freed or whatever. Um, so, yep, that makes sense. Ah, I see. So there's a sophisticated technique Ostep Python called arena allocation that involves kind of allocating within an already allocated region. Um, and yeah, there are reasons why you would want to do that, and it's a little complicated to explain. Um, but one of the problems is once you've allocated it, the address sanitizer thinks, it's fair game for anything. But if you're actually allocating a region of memory to be used by kind of a subsidiary memory allocator, then you want to be able to say, no, 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 this memory shouldn't be used yet. You need to do more like divvying of it up and giving it to somebody before you can use it. Is that a good explanation, Sir Elfman? And Ostet Feitel, did that advice on how to start programming in C++, was that helpful? So actually, I'll do a simple C++ program just as a demonstration. By the way, Ostet Feitel, never use Endel. It is evil and wrong, and there's millions of C++ tutorials out there that tell people to use Endel, and they're wrong. You should use \n, either like that or like that. That is what you should use. You should not use Endel. Endel is evil and bad. Sir Elfman thinks you should use printf. I disagree. I think that if you have the chance to use standard format, maybe that's what you should use instead. Or not standard format, actually, lib format. If you can use lib format, use that instead. But so we will do this just as a demonstration of how to actually run the compiler on Linux and have it produce an executable for you with a really simple program. There you go. That's how you do it. Um, if you have an IDE, it might get complicated. People, once projects get to be a certain size, you start needing CMake files or make files and all kinds of other uh, other frippery to make your program compile reasonably sanely. But early on, you can just get away with doing this simple thing here, and it works. Once you have some confidence in actually writing small, simple C++ programs that do tiny things, then you can start learning about all the stuff to make larger C++ programs more feasible to work with and compile and all of that other stuff. Oh, interesting. Is ZigCC related to Zig, Sir Elfman? Ah, there's a C++ compiler that's part of Zig. I'm not quite sure I understand what's going on there. By the way, Ostet Feitel, Zig is a programming language that Google came up with. That's kind of a competitor to C. And like most new programming languages, the programming language compiler is written in C or C++. Anyway, let's see here. What's left? Mercurial allows you to do what are called incremental commits. Incremental commits allow you to say line by line what you want to be part of the commit and what you do not want to be part of the commit. Actually, not line by line, like hunk of diff by hunk of diff. So yes, I want this by CPP mod mapper. And then that's the only change I wanted. There we go. And then the last change, this log message is going to be too big, and I have a thing that will catch that. And it tells me it's 81, so it's way too big. So let's there, that's better. Oh, so this is a way compiles that are independent of glibc. Oh, Ostep Vital. Well, it was nice having you here, and I hope that you have a good rest of your evening. Thanks for telling me that you're disappearing, since I told you that I couldn't tell whether you were here or not on YouTube. Interesting. You know that I have the POSIX PP project where my goal is to basically replace both libstd C++ and glibc with my own thing. And that one of the reasons why I'm doing this module mapper is I want to get away from the even. I want to be able to rely on the Linux kernel header includes to get values out of them, but I don't want executables built against my library to be directly dependent upon the Linux header files in any way. And so I want to use modules as kind of a firewall so that I can have all the pound define show up in the module and then they just disappear. And the only symbols that anybody who imports the module sees are the ones the module exports, which enables me again to firewall the Linux header files. Oh, that's so they had something, they put something in start which tries to interfere with the way the loader is using to go for to try and control which version of glibc is used, the dynamic loader. That's really obnoxious, honestly. POSIX PP, I had to write my own version of start. It was kind of fun. There's some, yeah. I had to learn exactly what it is the kernel has set up for you as your initial environment when the very first instruction of your program is executed. which is kind of it's interesting. There's actually the kernel put some stuff on the stack, I think, if I recall correctly. Hmm. Oh, that makes sense. This is actually a sticky situation for the POSIX BP thing is needing to work with old versions of the kernel API um, and having some kind of system set up to make that easy to kind of specify when you're using it. Partly because in new versions of the kernel API, I actually want to use like, if you call open or any of those functions, I actually want to use openat or openat2 even. I don't want to use the actual open system call anymore. But it would be nice to work on things that didn't have openat or openat2. So it's a tricky thing to it's a tricky thing to manage, and you kind of want ways to manage it at both compile time and runtime. I mean, it would be nice if something would at runtime go, what kernel am I on? What can I do? And then also at compile time, you can say, I don't care about running on any kernel that's later than earlier than blah blah blah, um, and have that decision like be made uh, in such a way that no code is omitted to try and work with the older kernels. Oh, that's interesting. I'm actually kind of wondering what impact I'll have on compile times once I actually get the dependency tracking implemented in this module mapper thing. Let's see here. Huh, neat. Let's see. RM, hello, blah, 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 blah. Do you know Python at all, Sir Elfman? Yeah, I really like Python too. It tends to be the language I reach for first when I want to get something done, unless I happen to know that I really need to use C++ either for speed reasons or because I need the kind of low level control you can get with C++. Why not? No web server backends in Python? What's wrong with that? uh, I would certainly much rather run my backend off of Python than Node. Although Python is slower. Let's see here. What do I need to do for dependency tracking? One thing I do kind of want is a dump DB. Yeah, that doesn't surprise me. I know that Facebook uses PHP, their own version of PHP internally, that they have also made very, very fast. Um, so maybe I should be calling them Meta now. I don't know. I worked at their Facebook. They'll always be Facebook. No, we're not going to do that. The Russians have their own Facebook. What's their Facebook called? Wonder if the Russians will ever start really using Rust. Let's see here. Hmm. Let's see here. So when I'm doing this, there's hello. So let's look at the log here. What does the log say? So here, so I need to keep track of in my protocol thingy. I need to start keeping track of all of the include files that people have asked for before I interesting. So let's see what goes on for middle A here. So here I'm compiling middle A. When I do this module, I see. So I do get the export before I get the imports. That's nice. So I'm doing an import of top and I'm saying, hey, here it is. Oh, I'm also saying, I see. I see. Hmm. You have gone silent, Sir Elfman. That's okay. It's nice to have you here in the hopes that maybe seeing that I have at least one viewer might cause somebody to be like, maybe I should watch that one. It's been a long time since I've been streaming. So I was looking through here to find out exactly what the order was between imports and exports and includes and all of that stuff. So it looks like with includes, I have to kind of keep track of oh, stupid thing. Come on, handle focus follows mouse properly. No, come on. There. One of the things I need to do here is make a dump DB as well, because I think I'm going to make it populate the database before it tries to dump the database. Um, yeah, uh, I have to get up for just a bit. So I am going to make myself disappear, but I will be back shortly. Partly, I want something to drink. My mouth is getting dry. I have gotten myself some water. All right. Should I make this a list of paths, or I'll make it a list of stirs? So, what does include translate look like? Yep, that's exactly what I want. AI completion for the win. And then here, handle module imports. No. And actually, just tells me something. I don't think append is the right word anymore. There. All right. There we go. Now, should I be recording the source name or not? It's a good question. One thing I should probably do at some point is double check to find out, are they trying to compile something in the modules directory? Because they shouldn't be using this to directly compile something in the modules directory. They should always be compiling something else that might import a module. And then it can call itself on whether it's going to be used for the modules directory or not. But I'm not going to add that check right now. That's correct. Now let's see here. Let's look at that does slash top. Then it returns back to at top. So at top never gets a module compiled. And it didn't get a module export before it got a module import. So there needs to be a state machine here. Yes, there needs to be a state machine. And the state machine needs a Python enum. And which version of Python am I claiming that I demand for my PyProject.toml? Okay. Aha. There is a way to do this. And I can say, no. I can see self.state. There we go. I'm not going to bother with this. I don't really care whether I've seen the module repo command or not. It's not relevant. But nope. Yes. Yep. All of them come in that. Yep. No, no, no. Yes, there we go. Okay. So, all right. Okay, why doesn't it let, oh, because it doesn't like the three S's. That makes sense. All right. All right. All right. Uh, oh ho. Well, that's very interesting. Oh, no, 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 that's perfectly allowed. There we go. Hmm. Includes a whole big bunch of stuff. No modules, which is exactly what I'm expecting. At the end of the top, we get all of this. Middle A, got module compiled. Middle A says there weren't any includes, which is true, and then there was a module top. Yep. Hmm. Little b, this top again, da 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 da, then middle b. This thing here with and then middle B depends on top, and that does bottom. Once it gets down at the bottom, it says yes, but it depended on middle A and middle B. All right then. All right. So this looks like it is collecting the dependency information correctly. I just realized here that in dep modules and dep headers, there we go. There we go. Oh, yes. I think I'm going to end it for the evening now, but I'm going to finish committing first. And we're going to run PyTest one more time. Good. Still works. Okay. Now, all right. There we go. All right. That's it for this evening. Um, I'm comfortable with having gone a significant way down this path and also having resolved several things, several questions that I had before I started actually writing code, including not knowing what questions I would have. That's one of the questions I would have, is what questions I would have. Um, and one of the important things is, oh yes, I need to keep track of both the source and the destination stat data for modules for various reasons. Um, so there is that. Um, and yeah, I will be fixing that. I think that's about uh, that's about it for now. Um, yeah, I hope that you have a good evening, Sir Elfman, and thanks for sticking around. Uh, and yeah, I shall be returning. Hopefully, I'll be returning this weekend, Saturday.